Hi, my name is Dr. English, and today we're going to be talking about atoms and ions. Specifically, we're going to look at atoms, obviously, versus ions, what a positive ion looks like, what a negative ion looks like, and then get some practice in the end. So let's first talk about what is an atom. Remember that an atom is the smallest particle of an element that can enter into a chemical reaction. And an atom is composed of three subatomic particles: protons, neutrons, and electrons. And we've talked about these before. Remember that in an atom, the number of protons will always equal the number of electrons. It's extremely important. So if you hear the word atom, protons and electrons will always be equal to each other. So when we look at this image of Mercury right here, we can say, well, the protons is going to be 80 because that's my atomic number. So there's 80. And therefore, if the protons are 80, the number of electrons have to be, you guessed it, 80. So what is an ion? Well, when a neutral atom, in other words, protons equal electrons, loses or gains one or more electrons, it's going to become charged, and then it's referred to as an ion. An atom that gains electrons are actually added to it, will become an ion and will have an overall charge that is negative. In other words, more electrons than protons when we look at the difference between the two. So there will be more electrons than protons. If the atom loses electrons to become an ion, it's going to have a charge that is positive, and therefore will have more protons than electrons. Now let's talk specifically about positive ions. These are ions with a positive charge. So an atom that loses electrons to become an ion will have an overall positive charge. The charge on an ion is found by subtracting, so we're going to look at this, subtracting the number of electrons from the number of protons that are given to you. So to figure out the overall charge, we're going to take our number of protons, which remember, that is your atomic number, and subtract it from the number of electrons that are given to you. So let's look at a sodium ion. We know that in sodium, the number of protons will be 11, and electrons are going to be 10. Now if I take the difference between these two, so if I subtract these two, I know that protons are positive and electrons are negative. So when I take the difference between these two, I'm going to have more protons than electrons. So my overall charge here is going to be +1. And that makes sense because if you look at your periodic table, and here's the image of sodium off your periodic table, you'll notice that the only charge that is listed here for sodium is +1, and that's something to keep in mind. At the same time, let's look at an aluminum ion. The number of protons for aluminum is 13, and I'm going to tell you that the number of electrons are 10. So again, we know that protons are positive, my electrons are negative. So if I take the difference between these two, between 13 and 10, I'm going to get a charge of +3. So when I look at the image of aluminum from your reference table, again, the only charge that is listed for aluminum is +3. So my results make sense. Now remember, on the chemistry regents exam, we're pretty much limited to the selected oxidation states that are listed on your periodic table. There might be one or two that are not listed that could potentially be used, but for the most part, you should always be checking your periodic table to make sure that your calculated charge matches up to the selected oxidation states that are listed on your reference table. Now let's look at negative ions. So remember, an atom that gains electrons to become an ion will have an overall negative charge, because if we have more electrons than protons, it's going to be negatively charged. So the charge on an ion, again, is found by subtracting the number of electrons from the number of protons. So to find the charge here, we're going to take our number of protons and subtract out our number of electrons. So in this example, let's look at oxygen. In terms of protons, oxygen has 8 protons. And I'm going to tell you that an oxygen ion will have 10 electrons. So protons are positive, electrons are negative, And if I take the difference this time, I'm going to have more electrons than protons, so the difference between them is 2, but now instead of being positive, it's going to be negative. I have more electrons than protons. This matches up, again, to what is on your reference table. The charge that's listed for oxygen is -2, so these make sense. Now let's look at phosphorus. Phosphorus has 15 protons and 18 electrons. So we know that protons are positive and electrons are negative. So again, let's take the difference between these two. So 15 is positive, 18 is negative. The difference between these two is 3. I have more electrons than protons, so this is going to be a -3 charge. And if I look at my symbol represented on my periodic table, I will notice that one of the charges listed for phosphorus is -3. So this is a possibility for phosphorus. Yes, there's other charges listed, but in terms of the information that I'm giving you in this example, my charge would be -3. So let's look at some examples of atoms versus ions. So this is an example of atoms. I'm giving you the symbol, the number of protons, and the number of electrons. So magnesium has a symbol of Mg. So if I look up the atomic number for magnesium on my periodic table, which again is my number of protons, it should be 12. And since this is an atom, and I recall that atoms, in an atom, protons will equal electrons, then my number of electrons here should be 12. For fluorine, the number of protons will be 9 because the atomic number is 9. Therefore, the number of electrons will be, 9. Germanium has the number of protons of 32. Therefore, the number of electrons are 32. So again, with an atom, the number of protons and electrons are going to be equal to each other. Let's now go and look at some ions. So a magnesium ion, and now I'm telling you that the symbol is Mg+2, and this +2 right here tells me that I'm working with an ion, so now protons are not going to equal electrons. So these two numbers are going to be different. Now I know that magnesium still has 12 protons. I can't change that. If I change the number of protons, I change the identity of the element. Because it's positive, my electrons have to be a lower number, and in this case it'll be 10. So if you're thinking, hey, that's 10, you're right. For fluorine, the number of protons again is still going to be 9 because that's the atomic number. But now my charge here is -1, so I'm going to have more electrons than protons. So in this case, the number of electrons is going to be 10. And finally, for germanium, germanium has a charge of +4. The number of protons, again, will still be 32, but I'm going to have more protons than electrons. So in this case, the number of electrons are going to be 28. And that is really looking at the difference between atoms, where protons equal electrons, and we see that trend all through here, and ions, where protons and electrons are not going to be equal to each other, so these two columns do not match. And I see the charge in the upper right-hand side. Okay. Now it's time to try some practice. So I want you to stop what you're doing, look at the element, the symbol of the ion that I'm giving you, and then tell me the number of protons and electrons that you would find for each one. Welcome back. Hopefully you've done the practice, so let's check your work. So strontium with the symbol of Sr+2. The number of protons will be 38 because that matches up to the atomic number. The electrons will be 36. Because there's more protons than electrons, the difference is 2, therefore it is a +2 charge. Nickel, I'm telling you that this ion of nickel is +3, therefore the atomic number is 28. So the number of protons is 28, and the number of electrons is going to be 25. 28 minus 25 will be 3, it's positive, so +3. Selenium with Se, 34 protons, 36 electrons. More electrons than protons, the difference is 2, therefore the charge is -2. Cesium, cesium will have 55 protons. It's +1, so if you said, hey, that's got to be 54 electrons, you're right. Tungsten with a symbol of W is +6. 74 protons, therefore for the number of electrons, because it's positive, we'll have 68. Because the difference between 74 and 68 is 6. Iodine, 53 protons because the atomic number is 53. It's a -1 charge, therefore the number of electrons, 54. And finally, nitrogen, atomic number is 7. It's a -3 charge, therefore the number of electrons, 10. So hopefully you got those right. So what did you learn? Well, we went over atoms versus ions. We talked about positive ions and how to figure those out. We talked about negative ions and how to figure those out. And finally, at the end, we did some practice. Need more help? Feel free to contact me. Have a great day.